Makinig, manood, nasa teleradyo. Makinig, manood, nasa teleradyo. Teleradyo, teleradyo Marcelo. Sa gitna ng mapanubok na panahon, magkahatid sa kakibat ay diskusyon. Sama-sama tayo, kahit magkalayo. Sa programang ito, tiyak ang pagkatuto. Teleradyo, teleradyo Marcelo. Teleradyo, teleradyo Marcelo. Teleradyo, teleradyo Marcelo.
Yeah, good afternoon, Delpilarians! Welcome to another episode of Physical Science. I am Sir Raymark Madlangsakay, your Physical Science teacher for today here at Teleradyo Marcelo, ang telearalan ng bawat malolenyo. I am happy to be here again for our 7th week. I would like to acknowledge our principal, Dr. Maria Victoria C. Vivo. Good afternoon, ma'am. My master teachers, Ma'am Rosita Lopre and Sir Bartolome Asa. Good afternoon po. Senior high school faculty, hello. And to grade 11 students who are tuning in with us here at Teleradyo Marcelo. And the others, of course. The future belongs to the curious ones who are not afraid to delve into it. So together, let us explore science and answer those questions in your mind. But before we proceed with our discussion, please bring out your learning modules, your notebook, and a pen so you can jot down notes. Okay? Reminder, don't forget to comment your name, grade, and section on our chat box to acknowledge your presence and all your answers to our activities and assessment for today's topic. Our lesson for today is about harnessing energy from different sources. But before we proceed in presenting our objectives for today, let's have a review from our previous lesson. Write your answer on the comment box and I will read some of them, okay? So let's begin with our question number 1. What does a catalyst do? A. Stabilizes a reaction. B. Cools the reaction down. C. Increases the rate of reaction. Or letter D. Increases the concentration of the reaction. Okay, so grade 11 students, if you know the answer, just comment your answer on our chat box below for me to recognize your answer. Okay, so the first student who answered with the question number 1 is... Okay, so we're still waiting for the answer. So we have student named Alexandra Grace Garcia. Her answer is letter C. And the correct answer is letter C, of course. So, a catalyst is added to increase the rate of a chemical reaction without itself undergoing any permanent chemical change. Now, let's proceed to our next question. Which reactant controls the amount of product formed in a chemical reaction? A. Composition. B. Excess. C. Limiting. Or letter D. Mole. Okay, so if you want to answer for our number 2 question, just share your answer with us using our comment box below. Okay. So, we have Charles Brian Banigan. His answer is letter C. So the correct answer is letter C, of course. Limiting reactants or limiting reagent is a reactant in a chemical reaction that determines the amount of product that is formed. And now for the third question. In order to determine the limiting reactant in a particular reaction, one must know each of the following except A. The coefficient of each reactant in a balance equation. B. The molar mass of each reactant present. Letter C. The mass of each product formed. Or letter D. The mass of each reactant present. Okay, please share your answer with us for our third question. So while we are waiting for the answer, please like and subscribe on our YouTube and Facebook page, Teleradyo Marcelo, ang telearalan ng bawat malalenyo. Okay. So we are still waiting for the answer for number 3. Just key in your answer on our chat box below for me to recognize your answer for this question. And we have Angel Bernardino, and her answer is letter C. So what is the correct answer? Okay, the correct answer is letter C. In order for you to determine which is the limiting reactant, it is important that you check if the equation is balanced. Mass in the molar mass of each reactant is also important. Mass of each product is important if you are asked how much of a certain reactant is in excess. Okay, it's so nice to know that you all really learned from our previous lesson. For today, you will learn about harnessing energy from different sources. These are objectives for today. Discuss the different sources of energy. Differentiate between renewable and non-renewable sources of energy. Explain how energy is harnessed from alternative sources such as fossil fuels, biogas, geothermal, hydrothermal, batteries, solar cells, and biomass. Before we could formally start our discussion, let us have some fun facts about energy conservation. Do you know, or do you often hear your mother reminding you not to keep the fridge open for too long? Yes, she had a reason. A very good one indeed. Every time you open the fridge door, approximately 30% of the cold air escapes. This basically leads to more power consumption and a higher electricity bill. Well, do you also know that some home electronics consume energy even when switched off? Approximately 75% of electricity used to power home electronics is consumed while the products are off. Televisions consume a lot of energy when turned off, which is used in the instant working of the TV, so we do not have to wait for a minute or two for it to start as soon as we switch it on. Keep them unplugged when not in use. Okay, let's proceed with our discussion. We all know that energy is defined as the ability to do work, right? It is indeed essential in our lives. Let us use your imagination. Try to imagine a world without energy. What does it look like? So class, try to imagine it. If the world without energy. I know that you are all imagining right now. Well, now that you have imagined what it's like without energy, and we also realize that we humans consume energy to carry out activities. The industry and agricultural sectors consume large amounts of energy to operate their machinery. In offices, energy is used to operate air conditioning units, computers, copying machines, electric fans, lights, and other electrical appliances. At home, we also use energy to make life more comfortable and convenient. In transportation, fossil fuels are used to run buses, trains, ships, airplanes, cars, and other types of transportation system. Given the energy plays a big role in carrying out different activities. We also need a big source of energy. With this, we also have the different sources of energy, and it is divided into two categories: the renewable and non-renewable sources of energy. Non-renewable energy includes fossil fuels such as oil, gas, and coal. The sources of this type of energy are only available in limited amounts. It will take a long time to replenish non-renewable sources of energy. For instance, the gasoline pumped at gas stations is made from crude oil that has been around in prehistoric times. Renewable energy is often referred to as a clean energy. This type of energy comes from natural sources or processes whose supplies are regenerative and virtually inexhaustible. Renewable energy sources can be replenished in a short period of time. These resources include biomass, hydropower, geothermal power, wind energy, and solar energy. Fossil fuels include natural gases, petroleum, and coal. We all know that fossil fuels are non-renewable, meaning the supply of these sources of energy is limited. They are mainly from plants that are subjected to high temperature and pressure for millions of years. Recall the plants involved here once stored energy from photosynthesis before they got fossilized. Also, fossil fuels are all hydrocarbons. This means that they are compounds formed from carbon and hydrogen. Fossil fuels are used to produce energy. At home, they are burned to produce heat. In large power stations, they are used to produce electricity, and they are also used to power engines. The bonds existing between the hydrogen and carbon atoms store energy. By burning the compounds in the presence of oxygen, the bonds are broken, and the stored energy is converted to heat energy, forming carbon dioxide in the process. Fossil fuels are burned to produce energy. In large power stations, they are burned in the presence of oxygen. As the fuel burns, the heat energy is used to heat water. As it is heated, it produces steam, which in turn rises and drives a turbine. The energy conversion goes from chemical energy stored in the fuels to heat energy as it burns. Heat energy is converted to kinetic energy as it drives large turbines, and finally, this is converted to electrical energy. In 2017, fossil fuels generated 64.5% of electricity worldwide. We are done with the definition of fossil fuels. Let us proceed with the formation of petroleum and natural gases. It starts with tiny marine plants and animals died and buried on the ocean floor. Over time, they were covered by layers of silt and sand. After millions of years, the enormous heat and pressure turned the remains into oil and natural gas. And today, we drill down through the layers of sand, silt, and rock to reach oil and natural gas deposits. Then, how coal was formed? Millions of years ago, giant plants died in swamps and were buried underwater and dirt. The heat and pressure turned dead plants into coal. We are done with the fossil fuels. Let's proceed with the biogas. Biogas is a type of biofuel that is naturally produced from the decomposition of organic waste. When organic matter, such as food scraps and animal waste, break down in an anaerobic environment, they release a blend of gases, primarily methane and carbon dioxide. An anaerobic environment is an environment that lacks oxygen. Because this decomposition happens in an anaerobic environment, the process of producing biogas is also known as anaerobic digestion. But what is anaerobic digestion? Anaerobic digestion is a natural form of waste to energy that uses the process of fermentation to break down organic matter. Animal manure, food scraps, wastewater, and sewage are all examples of organic matter that can produce biogas by anaerobic digestion. Due to the high content of methane in biogas, well, typically 50 to 75%, biogas is flammable and therefore produces a deep blue flame that can be used as an energy source. And to produce biogas, organic matter ferments with the help of bacteria communities. We have four stages of fermentation. Number one, the first stage of the digestion process is the hydrolysis stage. In the hydrolysis stage, insoluble organic polymers such as carbohydrates are broken down, making it accessible to the next stage of bacteria called acidogenic bacteria. The acidogenic bacteria convert sugars and amino acids into carbon dioxide, hydrogen, ammonia, and organic acids. At the third stage, the acidogenic bacteria convert the organic acids into acetic acids, hydrogen, ammonia, and carbon dioxide, allowing for the final stage, the methanogenesis. The methanogenesis convert these final components into methane and carbon dioxide, which can be used as a flammable green energy. Well, after discussing some of the non-renewable energy, we will now proceed with the renewable energy. The first one is geothermal energy. Geothermal energy refers to energy contained in underground rock and fluids. Thermal or heat energy deep within the earth may heat water or form steam. The geothermal energy is used to power steam turbines and generate electricity, although it can be used to heat homes and other buildings. This heat is a result of the increase in temperature of the earth with increasing depth below the surface. It is the energy which comes from inside the earth. That is the energy contained in underground rock and fluids. Geothermal energy is responsible for heating the water of hot water springs. It is considered as renewable energy because the heat at the center of the earth, which is a byproduct of chemical and nuclear reactions, will be replaced as the reaction inside the earth will continue to happen. Well, how does geothermal energy work? Hot water is pumped from deep underground through a well under high pressure. When the water reaches the surface, the pressure is dropped, which causes the water to turn into steam. The steam spins into a turbine, which is connected to a generator that produces electricity. The steam cools off in a cooling tower and condenses back to water. The cooled water is pumped back into the earth to begin the process again. Next is the hydropower. Hydropower plants capture the energy of falling water to generate electricity. It is considered as the country's largest renewable energy source. Hydropower takes advantage of the endless nature of water cycle, which constantly recharges the system through evaporation and precipitation. A turbine converts the kinetic energy of falling water into mechanical energy. Then a generator converts the mechanical energy from the turbine into electrical energy. Another source of energy are batteries, which store chemical energy that can be converted to electrical energy once a device is attached to them. Inside the battery is an electrolyte, which is a medium that allows the flow of electrical charge from the battery to the device. Batteries may be disposable or rechargeable depending on its chemical composition. A solar cell is an electronic device that catches sunlight and turns it directly into electricity. Solar cells are often bundled together to make larger units of solar modules, themselves coupled into even bigger units known as solar panels, or chopped into chips, to provide power for small gadgets like pocket calculators and digital watches. Just like the cells in a battery, the cells in a solar panel are designed to generate electricity. But where a battery cells make electricity from chemicals, a solar panels a solar panel cells generate power by capturing sunlight instead. They are sometimes called photovoltaic cells because they use sunlight. And lastly, the biomass or bioenergy. Biomass energy or bioenergy is the energy from organic matter, such as firewood, twigs, dead plant parts, cattle dung, livestock manure, and dead animal matter. This resource can be used to produce biofuels like ethanol, and biodiesel and biogas like biomethane. Plant leaves convert sunlight into chemical energy, which is stored in the plants. Animals that eat the plants store chemical energy in their bodies. Some of it also remains in manure and other waste. Biomass fuels are renewable because the raw materials can be produced simply by growing more crops or collecting more organic. These bioproducts reduce greenhouse gas emissions and decrease the country's dependence on imported oil while supporting agricultural and rural economies. After discussing the renewable and non-renewable energy, let's have a learning check. Do you still remember the difference between the non-renewable and renewable energy? Again, non-renewable energy includes fossil fuels such as oil, gas, and coal. The sources of these type of energy are only available in limited amounts, while renewable energy from natural sources or processes supplies are regenerative and virtually inexhaustible. Renewable energy sources can be replenished in a short period of time. Alright, well, for me, to know how much you learned from our session this afternoon, so let's have your assessment. Choose the letter of that corresponds to your answer. But let's proceed to number 1. Which of these is used to run turbines in thermal power plants? A. Water. B. Coal. C. Steam. Or D. Ice. Okay, so if you want to answer, just key in your answer on the chat box below. Okay. So, thank you so much for the 59 viewers that we have right now. Okay, so what do you think is the answer? So, I have here. So, there is an answer coming from Anthony Salamante. Letter C from Angel Bernardino. Letter B, Sean Marco Viray C. Alexandra Grace Garcia C. So, most of you answered number 1, letter C. So, let's take a look on the answer for question number 1. Later on, of course, yes. Just answer first the questions, then we will reveal it right after the last question. Okay, so let's proceed to question number 2. Which of these is a renewable source of energy? A. Solar energy. B. Hydel energy. C. Wind energy. Or letter D. All of this. Okay, so just try to answer it on your own first, and then we will reveal the answer right after the last question. Okay, so next question, number 3. The power plant which converts potential energy of falling water into electricity is blank. A. Nuclear plant. B. Thermal plant. C. Hydropower plant. Or letter D. Wind plant. Okay, next question, number 4. Which of the given is a non-renewable source of energy? A. Wood. B. Sun. C. Fossil fuels. Or letter D. Wind. Next, for the last question, number 5. In a hydroelectric power plant, more electrical power can be generated if water falls from a greater height because blank. A. Its temperature increases. B. Larger amount of potential energy is converted into kinetic energy. C. The electricity content of water increases with height. Or letter D. More water molecules dissociate into ions. Okay, so do you have your answer with you right now? Well, let's check your answers if you're correct. Okay, so let's have the answers. Let us reveal the correct answers to assessment. So we have C, D, C, C, and B. So try to check your own answer. Who got a perfect score, guys? Just put me, okay? Who got a perfect score? Just put me. Just key in me, M-E, for me to recognize if you got the perfect score. Okay, I think no one got the perfect score, but it's okay. I believe that you learned something from today's topic. Well, other than that, good job. Okay, oh, we have Nicole Aragon. So congratulations, you got a perfect score. Well, good job, guys. In case you encountered some mistakes on this assessment, do not hesitate to go back to your self-learning kit and review the concepts. Thank you all for actively participating in our session today, and see you again in our next episode of Physical Science here at Teleradio Marcelo. By the way, don't forget to like and share our episode today for your friends and classmates. Also, I would like to introduce to you the members of this episode's production team. Yours truly, Mr. Raymark C. Madlangsakay, your teacher broadcaster for today. Our scriptwriter, Engineer Sheila Marie P. Martinez, and our technical director, Russell Gerald C. Rayo. Well, lastly, I would like to leave this essential question to you. How can we be sure to never run out of energy? We cannot be sure about how much energy was left. Educate yourself and learn to conserve. That is all for today, guys. Stay safe and healthy. Thank you so much and goodbye. Okay. Ulo mo.
Makinig, manood, nasa teleradyo. Makinig, manood, nasa teleradyo. Teleradyo, teleradyo Marcelo. Sa gitna ng mapanubok na panahon, magkahatid sa kakibat ay diskusyon. Sama-sama tayo, kahit magkalayo. Sa programang ito, tiyak ang pagkatuto. Teleradyo, teleradyo Marcelo. Teleradyo, teleradyo Marcelo. Teleradyo, teleradyo Marcelo.